Alright, there's one shape we haven't talked about in terms of area, and this time we're going to do area of circles. Now they're a little bit special because they use different types of dimensions. Remembering when we did perimeter, we had to think about the perimeter being known as the circumference. Our area is still area, but it's a little bit trickier to think about. Keep in mind we're always going to be using dimensions that run either from the center out to the edge, which is known as the radius, or we are going to be looking at distances from edge to edge which pass through the middle, and this is known as our diameter. Now remembering our diameter is just two of the radiuses or radii stuck together. Okay, so you may recall from junior years that the area of a circle is equal to pi, a magical wonderful number, times radius squared, which can also be written as pi r squared, or it can also be written as pi times r times r. It all means the same thing. So let's actually use one of these. For example, let's get this right. Sorry guys. Here's a circle. Its radius is 10 centimeters. So our area will equal pi r squared, which is pi times 10 squared, which is pi times 100, which, just to be sure, let's get our calculator and practice finding pi. Pi is down here, so we have to go shift pi times 100, and that is 314.16. We're going to round, and remembering we are using squared units this time. Now that seems all well and good. Let's take a circle where this time we know that the diameter is equal to 12 centimeters. So we can't just launch into our pi r squared because we actually don't have a radius yet. So diameter equals 2r, or 2 times the radius. So we have to think about radius is equal to the diameter divided by 2. And that will equal 12 divided by 2, which equals to 6 centimeters. This time we can now use a radius because we have one, so it would be pi times 6 times 6, and if we get our calculator out, pi times 6 times 6 gives us 113 point, oh no, well we have to round that one, 0.10. Alright, so there are nice easy ones to start with. But I want you to start thinking about making this a little bit harder, because we're not always going to get a full circle. Now if I gave you a nice perfect half circle, that'd be really, really easy, wouldn't it? If that's a half circle and I told you that our diameter is equal to 16 centimeters, we know then our radius is 16 divided by 2, which is 8 centimeters, and you could actually just calculate the entire area. So you could say pi r squared, and then you could just divide the whole thing by 2, because we know we have half a circle. But it's not always going to be that easy. If you had a quarter circle, sure, you could do the same thing, and you could divide area equals pi r squared. You could divide that by 4, because you know there'll be 4 quarters in that circle. But it gets a little harder when all we have is how much of the circle we have in an angle form. So if I told you that circle had 120 degrees in it, knowing that an entire circle has 360 degrees, we now need to do something different. And our area becomes area equals, we're still going to have the pi r squared in there. We don't have to worry about this yet, that's my mistake, sorry. But we're going to multiply it by a fraction, basically, and this fraction is going to be how many degrees of the circle we have divided by how many we should have. So this time I'm going to give you the rule theta divided by 360 multiplied by pi r squared. So this is our area of a normal circle, and this is how much of the circle we have. So in this case we would have 120 degrees instead of a possible 360, and we're going to multiply it by pi times, or we didn't give you a radius, let's go with 7 centimeters. Pi times 7 times 7. So very simple on your calculator, the same type of idea. you would have to say, here's my bracket, 120 divided by 360. I'm going to shut my bracket. And then I can do the rest of my calculations. So pi times 7 times 7, shut my bracket. 51.31, when I do centimetres, so squared centimetres is our answer there. So this is a new rule for us because we are trying to find how much of the circle we have and then use that.